Alright, here we go, lesson 1.7, linear scale factor, surface area, and volume. So we're going to investigate the relationship between linear scale factor and surface area scale factor. So again, linear scale factor is just extending something in one direction. Surface area scale factor, remember surface area would be like a length times a width, so it gets extended in two dimensions. Okay, so the original dimensions, 3 by 5 by 1. So the surface area, if you multiply, we're talking about a cube here. So each dimension here, so I'll just draw a little cube. And so 3 by 5 by 1. Okay, so 3 times 1 is going to be 3. 5 times 1 is 5. 3 times 5 is 15. And then the same thing on the other side. So you're going to have 2 times 2 sides that are 15 centimeters squared. 2 sides that are 3 centimeters squared. And 2 sides that are 5 centimeters squared. So if you totaled that up, you would have 10 plus 6 is 16 plus 30. You're going to get your 46 centimeters squared. So we're dealing with a cube. So that's the first one, has a surface area of 46 centimeters squared. Now we're going to apply a linear scale factor of 2, which means we're going to multiply every dimension by a factor of 2. Now if I do this quickly here, instead of having a instead of having a 3 by 5 by 1 cube, we're now going to have a 6 by 10 by 12. So again, if we draw a little cube here, and we've applied a linear scale factor of 2, so everything's twice as big. So now we're going to have a prism that's 6 by 10 by 2. Okay, so 6 times 2 is going to be 12 centimeters squared. 10 times 2 is 20 centimeters squared. And 6 times 10 is 60. So then we're going to have 2 sides of 60. We're going to have 2 sides of 12. We're going to have 2 sides of 20 centimeters squared. Now if we add all this up, we get 184 centimeters squared, which is where that came from. So now we need to investigate the surface area scale factor. So if we take the new surface area of 184 and the old surface area of 46, and we reduce it to 4 over 1, we have a surface area scale factor of 4. So our linear scale factor was 2, and the surface area scale factor is 4. And if we remember from last day, that's because surface area scale factor gets stretched in 2 dimensions, so you have to square the linear scale factor. So 2 squared is 4. So let's look at the other ones. I'm going to go through these kind of quickly. If you have any questions, come talk to me. So here we go. We're having an original. The original one is 9 by 6 by 12. So if you do all the math, you're going to get a original surface area of 468. So again, 9 times 6 would be like 54 on the top, 54 on the bottom. 6 times 12, you're going to get 72 on the sides, and 9 times 12, you should get 108. So again, if you add all that, you're going to get 468. Then we're going to apply a 1/6 scale factor. So each of these dimensions gets reduced by a factor of 1/6. So you have a 1.5 by 1 by 2 prism. Okay, so 1.5. Let's see if I can zoom in a little bit for you here. Okay, So you have your old one is 468, and your new one is going to be 1.5 by 1 by 2, and your new surface area is going to be 13. So we take the old surface area, the new surface area of 13, and the old surface area of 468, and we get a area scale factor of 1/36. So the original one was 1/6. If we square 1/6, we'll get the area scale factor of 1/36. Okay. And the next one, 4 by 8 by 5. Again, if you draw a prism and you add everything up, you should get 184 centimeters squared. If you apply a scale factor of 3/2 to each one of these things, it's going to get a little bit bigger. So we're going to get a 6 by 12 by 7.5 centimeter prism. And then again, if you draw your prism and you add everything up, you should get 414 centimeters squared. So the new surface area is 414, and the old surface area is 184, which if you reduce, you should get a scale factor of 9/4, which if you square 3/2, you should get 9/4. All right, last one, 252. If you add everything up, apply a linear scale factor of 2/3, each one of these dimensions becomes 2 by 8 by 4. And the new surface area is going to be 112. So then we take the new surface area over the original surface area, and we should get something like 4/9, which is 2/3 squared. Okay, so that's area scale factor. Now area works in 2 dimensions. Like I was talking about, you're going to stretch one dimension this way and you're going to stretch one dimension that way. Now we're going to talk about linear scale factor and volume scale factor. So the thing about volume is, volume doesn't work in 2 dimensions. Volume is going to stretch in 1, 2, and then actually in the 3rd dimension. Okay, so that should be, picture you're drawing a cube, right? So you have it going in upwards, widthwise, and then actually the depth. Okay, so you're working in 3 dimensions. Okay, so volume, I'm just going to walk through the first one here. So we've got a 3 by 5 by 1 prism. So volume's a little nicer to work with. You just have to multiply each dimension by each other. So there is our prism, and it's going to be a 3 by 5 by 1 prism. So if we multiply 3 by 5 by 1, we get 15. We're going to apply a linear scale factor of 2. So this becomes 6, that becomes 10, and that becomes 2. So we get a 6 by 10 by 2 prism. Now 6 times 10 times 2 gives us 120. So then we take the new volume of 120 divided by the old volume of 15, and we get a volume scale factor of 8. Now if you notice, our linear scale factor was 2 and our volume scale factor is 8. So remember, there's our linear scale factor. And how many dimensions are we working in? 1, 2, 3. So we're going to cube it, and we should get 8. Alright, so let's deal with this last one here, or the next one, sorry. So again, on a scrap piece of paper, you can draw yourself a little prism. And this prism is going to be 9 by 6 by 12. So 9 by 6 by 12. Alright, if you multiply 9 by 6 by 12, you should get 648 centimeters cubed. We're talking volume. We're going to apply a 1/6 scale factor. So 9 again becomes 1.5, 6 becomes 1. If you divide 12 by 6, you'll get a 2. So we now have a 1.5 by 1 by 2 prism. So I'm just going to zoom in here. So you have a 1.5 by 1 by 2. If you multiply 1.5 times 1 times 2, you should get 3 centimeters cubed. So the new volume is 3, and the original volume was 648. Should be a 4, 648. And if we reduce this, you actually get a volume scale factor of 216. So if we look at what our scale factor was, our linear scale factor is 1/6. Now we're working in 3 dimensions, so if you cube 1/6, you'll get 1 over 216. 6 times 6 times 6 is 216. Okay, let's zoom back in for the next one. Okay, so you've got a 4 by 8 by 5 prism. 4 by 8 by 5 prism. Now if you multiply that all together, you should get 160. And we're going to apply a 3 over 2 scale factor, so each one of these things gets multiplied by 3 over 2. And you'll end up with a 6 by 12 by 7.5 prism. So if we multiply 6 by 12 by 7.5, you're going to get a new volume of 540 centimeters cubed. So we take the new volume, 540, over the original volume of 160, and if we reduce that, we'll get 27 over 8. And again, if you take the original scale factor of 3 over 2, we're working in 3 dimensions, so you're going to cube that. You'll get that 27 over 8. Alright, last one, 3 by 6 by 12. If you multiply all those things out, you should get 252 centimeters cubed. We're going to apply a scale factor of 2 over 3 to each dimension. So your new prism is 2 times 8, 2 by 8 by 4. Now if you multiply that out, you get 112. And if we take our new volume, 112, we divide it by the original volume of 252, you'll get, if you reduce it, a volume scale factor of 8 over 27. And again, that would be 2 over 3 cubed equals 8 over 27. Okay? So this page is kind of a recap of what we've talked about already. Linear scale factor in ratio form A to B or A over B. I kind of prefer A over B. This ratio describes an enlargement or a reduction in one dimension and can be calculated using new length over original length. So again, if you have a new length that's greater than the original length, your scale factor